Hi, welcome to this tutorial on Sketcher. In this tutorial we are going to see Introduction to Sketcher, and we will talk about two options, that is grid and snap to point. So let's begin with Introduction to Sketcher. Open CATIA V5, go to File, say New, click on Part. Once you click on Part, you enter into a workbench, that is a mechanical design. In that you enter into part design. Okay, so click OK. To mechanical design, in mechanical design you are into part design. So we are talking about mechanical design workbench. Now in order to enter into Sketcher, this is the icon. Click on Sketcher, select any plane, and now you are ready to do sketching, whatever sketching you want to do. You have a lot of options here. You can see rectangle, circle, lines, whatever you want to do, you can do. Okay, if you want to get out of the Sketcher, this is the option. It is exit workbench. You can click on this and you can exit the workbench. Okay, now you can enter into another workbench also. It's not like you have to be within the same workbench. You can enter into another workbench also. Let us say if you want to enter into shape. In shape, generative shape design, say OK. Here also you can find Sketcher. So click on Sketcher, select a plane, using this all tools. Okay, do whatever you want. Let's go back to mechanical design, part design. Let's go to Sketcher, select the plane. Now you can see there are different tools available here. You can see the rectangle. In rectangle you have different types of, make different types of shape using rectangle. You have circles, different types of circles. Similarly you have lines, different types of lines. You can use all these commands and you can make desired sketches. Okay. Let's talk about it one by one in coming videos in more detail. Let's see the next two options. There's a grid and snap to point. You can see the grid on the top. It is into sketch tool. This you can drag it. It is named as sketch tools. Here you can see the grid and here you can see snap to point. In case if it is not visible on your toolbar, you can right click on this bar, go to customize, go to toolbars, restore all contents, say OK, restore position, say OK. So you'll find the sketch tool is visible now. You can drag it to some corner. Okay, so let's see the sketch tools. First the grid. If it is in blue color, it is off. If you click on it, it will turn into orange color, and now it is on. So you can see the difference. If we off it, the entire screen is without grid, and if it on it, the entire screen has a grid. Now this will be helpful for you when you do sketching. It will assist you to give dimensions, the sketches to the models. Okay. The next option is snap to point. Let us see what is snap to point. Click on it. Let's try to make a rectangle. Let's click the first coordinate. Now snap to point is assisting us, and it is only allowing us to take the corner of each grid. You can see it. Okay, it is snapping to the corner of the grid. Okay, it will not allow you to take any coordinate between the grid. Okay, let us say if we switch it off, let's try to see the difference. Again, I have taken the first coordinate of rectangle. You can set any dimension of the rectangle. You can take the point at the center of the grid too. So I don't find this snap to the point of much useful, and For the next set of lectures, I will be keeping this off. Hi, welcome to this tutorial on Sketcher. In this tutorial, we are going to see line profile, rectangular profile, and dimensions. Yeah, so guys, let's see how to draw a line in CATIA V5. Let's click on File. Let's go to New. Select Part. Click on OK. We need to enter into Sketcher. So click on Sketch command. Select any desirable plane that you want. On the right toolbar, you can see the line command. Now line can be drawn in different ways depending on the situation. Let's click on it and see the different ways of line. The different ways to draw a line. Okay. Let's see the first time. Click on line. This is the simplest part. Click for the first point of line, that is the start point of line, and click again for the end point of line. Click outside and you will see the line is drawn. Let's try it one more time. Click on the line, select the start point, select the end point. Click it outside and your line is ready. Try one more time. You can practice it by drawing different lines. Now let's see the second type of line. The second type of line is infinity line. For this, you need to define a specific point and a horizontal line will be drawn. This line can be used as a reference line also. So let's see the third type of line. That is a bitangent line. For this, the pre-requirement is 2 circles or 2 arcs. We will see in more details about the circle when we talk about the circular profile. For reference, just I will draw 2 circles randomly. Now let's go to line, click on bitangent line, select the 2 circles. You will find a line is drawn which is tangent to both the circles. Let's try one more time. Click on the line, select 2 circles, and you will find the line drawn tangent to 2 circles. Let's see the other type of line. Bisecting line. Let's draw a line which is bisecting to these 2 lines. So select line 1, line 2, and you will find a line is drawn which is bisecting these 2 lines somewhere here. Okay. Let's try it one more time. Let's draw 2 simple lines intersecting each other, and let's draw a bisecting line to these 2 lines. Select line 1, select line 2, and you can see a line is drawn which is bisecting to these 2 lines. Let's see the last type of line. Line normal to curve. For this, the pre-requirement is there should be a certain curve. Here we have taken the circle. Okay. So let's click on line normal to curve. Let's click on any point on the circle, and you can see the line is drawn which is normal to the curve. Let's try one more time. Line normal to curve. Click at a point on the circle and you will find a line is drawn which is normal to the circle. So that's all about line. You can practice by drawing various lines and you can complete the assignment given in next file. And you can complete the assignments given in file 5.1. That's all about lines. You can practice it again and again randomly. After that, you can complete the assignment given in file number 5.1. So let's see how to draw a rectangle. So to go to rectangular profile, you can click on Insert, go to Profile, go to Predefined Profile, and you can see the rectangular profile. Same thing you can see on the right vertical toolbar, rectangular command. If you click on this arrow, you will be able to see different profiles, which we will see one by one. Let's start with the rectangle. So in order to draw a rectangle, click on this command, click to define the first point and drag it wherever you want, and click once again to define the diagonally opposite end of rectangle. So this is how the rectangle is drawn. Let's repeat it once again. Click on the command, click for the first point, click once again to define the opposite edge of the diagonal. And here the rectangle is drawn. Okay, you can repeat it and try to draw some rectangles. So let's see the next profile, oriented rectangle. Now in order to draw an oriented rectangle, you need to define 3 points. First, the start point of edge and the end point of the same edge, then the height of rectangle. So here you get a oriented rectangle. Let's try one more time. Click on the profile, define the first point, that is the start point of the edge, end point of the edge, and then the height of the rectangle. Now this symbol tells you that the edges are parallelly constrained. In this case, this symbol is meant for this edge and this edge. Both are parallel. Similarly, this symbol tells you that edge, this edge and this edge, both are parallel. Let's see the next command, parallelogram. Here also we need to define 3 points. What is the difference between rectangle and parallelogram? Opposite edges are parallel to each other in both the cases, but adjacent edges are not at right angle to each other. Okay, so let's see how we can draw the parallelogram. First we need to define the start point of the first edge and the end point of the first edge, and you can drag it anywhere and click it to form a parallelogram. Let's try one more time. Click on the profile, define the first point, define the second point, and define the height. In this way you can draw a parallelogram. Let's see the next command, elongated holes. In this we need to define the center point of the semicircle of the holes. So let's click point 1, point 2 and drag it. You can see the elongated hole is formed. Let's try one more time. Click point 1, click point 2, drag it. And you will find the elongated hole is drawn. So let's see the next command, that is cylindrical elongated hole. For this you need to click on the command. The command is here, cylindrical elongated hole. In order to draw cylindrical elongated hole, you need to define 3 points. The first point is going to be the center of the circle along the circumference of this circle, the hole is going to get elongated. The next point will be the radius of the circle, also the center point of first semicircle of the elongated hole. Now drag it and define the third point. You can just drag it to see that your elongated hole is ready. Let's try one more time. Click on the command, click first point, click second point, click third point and drag it. Cylindrical elongated circle is ready. Let's try one more time. First point, second point and third point. Just drag it. Okay. So let's see the next command, keyhole profile. This is the command for keyhole profile. In order to create a keyhole profile, we need to define point 1, point 2. This will be the length from center to center of keyhole profile. The third point will define the radius of the base, and the fourth point will define the radius of the top. And this is how the keyhole profile is created. Let's try one more time. Click on the command, define the first point, define the second point. This will be the length from center to center of the keyhole profile. The third point will be the radius of the base, and the fourth point is going to be the radius of top. This is how the keyhole profile is created. So let's see the next command, that is hexagon. So click on the command of hexagon. In order to draw a hexagon, you need to define 2 points. First is the center of the hexagon, and the second point will be the distance of the edges from the center point. So this is how the hexagon is created. So let's try one more time. Point 1, that is the center of the hexagon. Point 2, that is the distance of the edges from the center point. And this is how the hexagon is created. Let's move on to the next command. The next command is centered rectangle. Here we need to define the center of the rectangle, and you just need to drag it and your rectangle will be ready. Let's try one more time. Define the center point and drag it, and your rectangle will be ready. This is how the centered rectangle is created. So let's see the next command, that is centered parallelogram. To draw a centered parallelogram, we need an intersection point. So let's create an intersection point by drawing 2 lines. Now select the command of centered parallelogram. Take both lines. Now you can see that the parallelogram is taking its center at the intersection point of 2 lines. Let's try one more time. Let's create a rectangle. Now let's create a centered parallelogram. Let's take these 2 lines. Now you can see that it has taken this intersection point of 2 edges of rectangle as its center. Click it. Okay, this is the way you can draw a centered parallelogram. So this is all about the rectangular profiles. So now we will see how to give dimensions to the sketches. So linear dimensions and angular dimensions. So to start, we will draw a rectangle and try to give the dimensions. You can see this is the command for giving dimensions. It is called as constraint. So this is the command for giving dimensions. It is called as constraint. So click on this and click on the line where you want to give the dimension. Let us say we will click this line, drag it up and click one more time. So you can see this edge or this line we have given dimension. Now we can edit this dimension by double clicking on it. You can see a small pop-up window. You can change it according to your requirement. See. 100. Okay. So now it has changed to 100. Let's try to give dimension to this vertical edge. Click once again to constraint. Now in place of clicking this line, we will click these two lines and we will see how the dimensions are taken. So now you can see the dimension we have given to this line by clicking these two edges. Okay, let us change it. Okay. So now if you want to give dimension to one more edge, let us try to give dimension to this edge. Let's click on command and give dimension. Now you can see the color of the rectangle has changed to purple. This shows that your sketch is over constrained, and your sketch should never be over constrained. So whenever you see that your sketch has turned to purple, just try to remove some dimensions, and now you can see the sketch is back to normal. Now let's try to give some angular dimensions. For that, let's draw a line. Click on constraint. Click on constraint. Select this edge and select this edge. You can see the angular dimension. Now you can change the dimension as per your requirement. So in this way we can give the dimensions. Few more important things we will see. Now let's try to edit this. Now you can see the angular sector. Here you can change the sector. Let us say sector 1. You can see there is a change in the dimension. Let us select sector 2, sector 4. By default it will take the shortest dimension, but sometimes it's not the same case. So in that case you can select the sector according to your requirement. Click OK. Hi, welcome to this tutorial on Sketcher. In this tutorial, we are going to discuss about circular profile and spline. So let's start. Open CATIA V5. Click on File, New, select Part, select OK. Get into Sketcher, click on Sketch. To see the circular commands, go into Insert, Profile and Circle. You can find different circular profile here. Similarly, on the right side, you can see the circle command. If you click on this, you can see other options of drawing the circle and arc. So let's see one by one how to draw a circle. So to draw a circle, click on this command, select a center point, drag it and select one more point. Okay, let's try one more time. Click on the command, select the center point, drag it and click it. Okay, you can give dimensions by clicking on constraint and selecting the circle. Okay, as discussed, you can change the dimension also. Okay, let's see the next type of circle, that is 3-point circle. Click on this command. You need to click 3 points, point 1, point 2 and point 3 to draw the circle. Let's try one more time. Click on the 3-point circle command, point 1, point 2, point 3, and this is how the 3-point circle is drawn. So let's see the next command, circle using coordinate. So this is the command. Click on it. You will see a window, pop-up window. Here you can define the coordinate of center. So let us say if we are putting 30 along x-axis and 40 along y-axis. Define the radius of a circle 80 mm. Click OK. You can see the circle is drawn. The radius is 80 mm and the center is at a coordinate of 30, 40. So in this way you can draw circle using coordinate. Now let's see the next command. Tritangent circle. In order to draw a tritangent circle, you need 3 surfaces or 3 lines. Let's draw 3 lines. Let's click on tritangent circle. Select 3 lines and you will see a circle is drawn that is tangent to all the 3 lines. Let's try another example for this. Let's draw a rectangle. Click on tritangent circle. Click 3 lines and you will see a circle is drawn which is tangent to 3 lines. Let's try another command. This is a 3-point arc. For drawing 3-point arc, you need to select 3 points. And this is how you draw the 3-point arc. Let's try one more time. Point 1, point 2, point 3. Okay. Let's try the next command. This is also a 3-point arc, but it is starting with the limits. So let's click on it. Select point 1, point 2. This will define the limit of the arc. Then you can select the point accordingly. Let's try one more time. Point 1, point 2 and point 3. Let's go to the next command. There is arc. For this you need to click one point to define the center of arc. Click second point to define the start of the arc and click third point to define the end of the arc. Let's try one more time. Point 1 center, point 2 start of the arc, point 3 end of the arc. Let's try one more time. Click on the command, select the center point, select one more point, select the third point. So this is how the arc is created. You are requested to practice all the circular profile again and again. Also complete the assignments given in file 6.1. So now let's see how to draw a spline. For that you can go to Insert, Profile, Spline. And this is where the command lies. You can also see it at the right vertical toolbar. This is the command for spline. Click on this and draw a spline by clicking random points. You can see the spline is created. Let's create a close loop. In order to come out of the command, press escape on your keyboard. So let's see one more example of spline. So click on the spline command. Point 1, point 2, point 3, point 4. Now if you want to make a closed loop, you can right click it and say close spline. So it automatically closes the loop. Let's try one more time. Spline, point 1, point 2. Now let's say if you want to close the loop, click right click or click button number 3, say close spline, and you can see the loop will be closed. Let's try one more example. Let's create some points before drawing a spline. This is the command of creating points by clicking. So let's click some points. 1, 2, 3, 4, 5, 6. Press escape. Now click on spline. Let's connect this point by spline. Let's close the loop. So this is the way of creating the spline. There are certain rules of drawing spline. We will see it once we start designing the product. Now let's see how to connect the curves or lines by using a spline or by using a command called connect. So in order to see this command, you can see the command here, that is connect. So in order to use the application of it, let's draw a spline and let's try to connect these 2 points. In order to connect the 2 points, click on connect, select point 1, select point 2. It will get connected by spline. Let's try another example. Let's say we have 2 lines and we want to connect it by spline. So click on the command of connect, select point 1, select point 2, and you can see it is the 2 points are connected. Let's try to connect these 2 points. So this is the way of connecting 2 points. So this is all about circular profile and spline. Before we move on to next video, practice it once, twice, thrice. Thank you for watching this video. Let's meet in next video. Hi, welcome to this tutorial on Sketcher. In this tutorials we are going to see axes, profiles and points. So let's begin with axis. In order to draw an axis, we need to enter Sketcher. Once we are into Sketcher, you can click on Insert, Profile. Here you can find the axis command. You can also find the axis command on right side toolbar. Here you can see the axis command. So in order to draw the axis, click on this command. Select the endpoints of axis and you can see the axis is drawn. So let's try one more time. Click on the command, click the first point, click the endpoint. And in this way you can create an axis wherever required to draw a sketch, to make a model or during assemblies. So let's see how to create a profile. In CATIA V5 we can create a profile with a combination of lines, arc and circle using a single command, and that is called as a profile. In order to draw a profile, you need to enter into Sketcher. After that, click on Insert, click on Profile, and you can find the profile command here. You can also find this command on right hand side vertical toolbar. So this is the command. So let's see a few examples how to create a profile. The first profile we will see by creating lines that are connected to each other. So this is the way you can create a profile. You can make a closed loop or you can keep an open loop. So this is the way we can create a simple profile. Let's try one more profile with a combination of lines and arc. So point number 1, point number 2. So this is the line, point number 3, this forms the second line, point number 4. Now if you want to create a circular profile here, you need to hold button number 1 and drag it. And you can see a circular profile is formed. So click for the endpoint, try one more time, drag it, and you will see the circular profile is formed. Try one more time. And this is how the profile command is used in order to create a non-standard or an irregular profile. So let's try one more example of creating a profile using a combination of lines and circular profile. So click on the profile command, click point number 1, point number 2 to create the first line, point number 3 to create the second line. Now if you want to create a circular profile here, click and hold button number 1 and drag it. You will find a rectangle is formed. Now leave it. You will see a circular profile is created. Click to define the endpoint of circular profile. Again, if you go, a straight line is created. Click for the next point. Again, if you want to create a circular profile, drag it and a circular profile is created. So click for the endpoint, and this is the simple way of creating the profile. You can practice it to get more hands-on on this command. So let's now see how to create points. So in order to create points, enter into Sketcher, click on Insert, click on Profile. Here you can see a point commands. You can see points can be created by different methods. So the same command you can find also on the right hand side toolbar. You can see this is the command for creating the points. So let's begin and start creating different points. So in order to create the point by clicking, click on this command and you can click randomly wherever you want to create the points. This is the simplest way of creating the points. So let's try one more time. Click on the command point by clicking and you can randomly click. If you want to create multiple points, double click on this command and you can click continuously to create the points. So this is the simplest way of creating the points. So let's see the next type of point, the creation of point by coordinates. So click on the command. You will see a pop-up window. Here we need to define the coordinates of the point. This is the horizontal and this is the vertical coordinate. If you are using a XY plane, horizontal is going to be x-axis and vertical is going to be y-axis. So let's create a point at a coordinate of 20 horizontal and 30 vertical. Click OK. You can see a point is created here, which is at a distance of 30 from the horizontal axis and 20 mm from a vertical axis. Let's try to create another point. Now before entering the coordinates of the second point, you need to take care that the second point will be created taking first point as a reference point. So if you are entering horizontal 10 mm and vertical 10 mm, it will be with reference to the first point. Click OK. So you can see a point is created which is at distance of 10 mm horizontal from the first point and 10 mm vertical from the first point. Similarly, let's try to create a third point which is at a distance of 15 mm horizontal, 20 mm vertical. So this will be with reference to the second point. So click OK and you can see the 3 points are created. So you need to take care when you are using this command that whatever next point you are going to create, it will be with reference to the previous point. So this is also the simple way of creating points. Now let's see how to create other points. So the next type of points are equidistance point. This command is used to create the points at equal distance. So for this, either we need a reference line or reference curve. Let's try to create equidistance point using a line. Let's draw a line of 100 mm. Click on equidistance point command and select the line. You will see a pop-up window. Here we need to define the number of points that we want to create. Let's try to create 10 points. Say OK. Now you can see 10 points are created at equidistance on the line. So let's see the points in detail by deleting this reference line. So you can see point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 points are created at equidistance. Let's try one more time. Let's try to create equidistance point using spline as a reference. So click on the spline command, draw a spline, click on equidistance point command, select the spline, enter the number of points that you want to create. Let's say around 5 points I want to create. Click on OK. And you can see the 5 points are created. If you want to see it clearly, delete spline. You can see the points are created and all these points are equidistant from each other. So this is one of the simplest way to create multiple points. Let's try the next command, intersection point. Now in order to create an intersection point, you need two lines intersecting to each other. Let's draw two reference lines which are intersecting to each other. So you can create a point at the intersection of these two lines by using the command intersection point. Click on the command, select line 1, select line 2, and you will see a point is created at the intersection of these two lines. Let's try another example. Let's create a rectangle. Let's try to create an intersection point. Select edge 1, select edge 2. So you can see a point is created at the intersection of these two edges. In this way you can create the point at the intersection. Now let's try the next type of point, that is a projection point. In order to draw a projection point, you need to draw some reference point. Let's draw few points. Now this command is used to create the projected points on a line, on a plane or a surface. So let's create a line and try to see how this command is used. So click on the command, select the points, select the line. Now you can see the points are created. Let's try another example. Let's create reference points. And try to project them on a spline. So click on projection point command, select the points and then select the spline. You can see the projected points are created on the spline. So that's all about creating a points. You can practice it. You can carry out the assignments. Keep practicing till you get confidence. Thank you for watching this tutorial. Let's meet in next tutorial. Hi, welcome to this tutorial on Sketcher. In this tutorial we are going to see conic profiles. In conic profile we will see how to draw ellipse, parabola, hyperbola. So let's begin with the first command, that is ellipse. In order to see the commands in conics, click on insert, go to profile and go to conics. Here you can see all the commands, that is ellipse, parabola, hyperbola and conic. Similarly, you can see the same commands on the right side toolbar. Here you can find all the commands, ellipse, hyperbola, parabola and conics. So let's see how to draw ellipse first. So click on the command of ellipse, click point number 1 to define the center of ellipse, point number 2 to define the major axis of the ellipse, point number 3 to define the minor axis of the ellipse, and in this way you can draw the ellipse. Let's try one more example of ellipse. Click on the command, click for center point, click for major axis, click for minor axis. Now you can give the dimension of this ellipse. This is the minor axis, this is the major axis. You can change the dimension as per your requirement. Okay, so this is the way you can define or give dimensions to the major and minor axis of the ellipse. Let's try one more example. Having the dimensions of major axis as 100 and minor axis as 50. So this is the way of creating ellipse and giving the measurements of major axis and minor axis. So the next command is parabola by focus. In order to draw a parabola, we need to define 2 points. One is the focus and second is vertex. Let's see how to draw a parabola. Click on the command of parabola by focus. Click once to define the focus and click second time to define the vertex. You can see based on the vertex, size of the parabola is changing. So let's click, define the endpoints of parabola and you will see the parabola is created. Let's try one more time. Click on the command, define focus, define vertex, then define the endpoints of the parabola. In this way you can draw the parabola. To know more about the parabola, you should know the mathematics behind the parabola. So try to read about the parabola. Once you learn about it, it will be very easy for you to draw in CATIA and you will understand where it is going to be used. So now let's see the next command, that is hyperbola. In order to draw a hyperbola by focus, here we need to define 3 points. One is the focus, second is the vertex and third is the semi-major axis. So we will see the sequence of defining the points. The first point will be the focus, second point is going to be semi-major axis and third point is going to be vertex. So based on the point of vertex you can see the hyperbola is changing. So let's click here and now let's define the endpoints of hyperbola. So let's try one more time. Click on the command, define the focus, define semi-major axis, define the vertex and the endpoints of hyperbola. So this is the way we can draw the hyperbola. To understand more, we need to understand the mathematics behind the hyperbola. So you can just read the document on parabola and hyperbola so that you can get more idea what is the mathematics behind it and how it can be used in CATIA V5. So guys, let's see the last feature in Conic. So let's click on the command. So it is named as Conic. So let's see how we can draw a geometry using this feature. In order to create a geometry which is similar to a parabola or hyperbola, using this Conic, we need to define 4 points. And all the 4 points will define the boundaries of the conic profile. So let's try the first point, second point, third point, and let's click the fourth point, and then you can drag it. So you can see in this way the profile is created. Let's try one more time. Click on the command, define point 1, point 2, point 3 and point 4. So in this way you can see the profile is created. This is all about the conic profile. To know more on it, you have to study the mathematical equation of hyperbola, parabola and ellipse. And this is going to really help you to understand the details of this geometry and their applications when you are going to design a product. So thanks for watching the video. Hi, welcome to this tutorial on Sketcher. In this tutorial we are going to learn conversion of standard and construction element. We are going to see how to edit sketches manually and by using constraint feature. We will see AutoConstraint, contact constraint and fix together. So let's begin with conversion of standard and construction element. So now let's see how to convert standard element to construction element and vice versa. For that, let's create a standard element. Let's try to create a rectangle. Now if you want to convert any of the edge into construction element, you can do it by using a command construction standard element. Now let us try to convert this standard element into construction element. So click on this element and click on this command. So now you can see the standard element got converted into construction element, and the construction element looks like a dotted line. Now if you want to convert this construction element into standard element, select this line, click on the same command. You can see the construction element is converted to standard element. Now let's learn editing the sketches. This can be done manually or by using constraint. Let us take few examples and try to understand how the sketches can be edited manually and by using constraint. So for that, let us go to part design, select sketches, select the plane. Let's take an example of line. Let's draw a line. Now this line can be edited manually or by using constraint. In order to edit it manually, select the line, grab it and drag it. You can change the position or location of line. If you want to manually change the length of the line, select any endpoint of the line, grab it and drag it. You can change the length of the line. Similarly, you can select other end and drag it. So in this way, manually you can edit line. Let's see how to edit the line by using constraint. Select the line, select the constraint command. Now you can edit the length of the line. You can also fix the position of line with respect to origin of the coordinates. Let's try it. Select the constraint, select the line, click on the 0, 0 coordinate. So you can see the entire line has become fully constrained. You can change this dimensions. Let's take one more example and try to understand. Let's draw a rectangle. Now if you want to relocate or change the position of rectangle, you can select it. You can hold your cursor on any edge, grab it and drag it. And you can change the position of rectangle manually. If you want to change the dimensions of edges, select any corner, grab it and drag it. So in this way, you can change the dimensions or edit the sketches manually. Let us see how we can edit the sketches by using constraint. Select the edge, click on constraint command. Now you can edit the dimension. Let us see 50. Click on the other edge, click on constraint command and you can edit the dimensions. Now the rectangle is visible in white color. All the edges are in white color. That means it is not fully constrained. So further you can make it fully constrained by selecting the edges, selecting constraint. Now you can edit it. Now you can see the two edges are fully constrained, whereas two vertical edges are still under constraint. We can make them fully constrained by clicking the edge, clicking the constraint and clicking the point of origin of coordinate system. Okay, let's make 100. In this way we can edit the sketches using constraint. Let's try one more example. Let's draw a circle. You can select the center point, grab it and change the location. If you want to change the diameter, click on the circle, drag it and you can change the dimensions of the circle. Let's do it by using constraint command. Select the circle, click on constraint and you can edit the dimensions. You can either give diameter or you can give radius. It's up to you. Let's try one more example. In some cases, you may not be able to edit the sketches using constraint. Let's see such example. Let's draw a circle. Let's draw a rectangle. Let us give dimension. Now if you want to edit the rectangle and bring this horizontal line above the circle. So one way is we can edit the sketch. We can put -10 so that this edge will be above this circle by 10 mm. Let's try. But in this case it is not happening. It is not taking a negative measurement. Okay, let's cancel. So how we can do it? In this case we need to do manually. Select the edge, grab it by holding button number 1 and drag it above the circle. Now you can give dimensions. So this is the way sketches are edited manually and by using constraint command. That's all about editing sketches in CATIA V5. So now let's see the next feature, AutoConstraint. You can locate the AutoConstraint on right vertical toolbar here. This is the command for AutoConstraint. AutoConstraint is used for quick dimensioning the geometry. So let's understand with an example. Let's draw a geometry. Let's try to use AutoConstraint command and give dimension to this geometry. So select the geometry, click on AutoConstraint. You can see a pop-up window which will tell you the detail about the number of lines that you have selected. So you can see elements to be constrained. So we have 5 lines. Click OK, and now you can see the dimensions are created for entire geometry. So this is the way AutoConstraint is used for giving quick dimensions to the geometry. Let's try to delete and try to understand what will happen if we use only a part of geometry. So whether it is possible to give dimensions to the partial geometry. So let's select these 2 lines and click on AutoConstraint. So again we will see a pop-up window. Here it is mentioned 2 lines. So we have selected only 2 lines. Click OK. So now you can see the dimensions are given to the 2 lines. In this way, you can use the AutoConstraint feature to give quick dimensions to the entire geometry or part of a geometry. That's all about AutoConstraint in CATIA V5. So let's see the next feature, Contact Constraint, and try to understand how this contact constraint can be used in Sketcher. Contact Constraint tool can be located on vertical toolbar. You can see here. This is the command for Contact Constraint. So let's try to understand with some examples. Let's create a geometry. Let's create a rectangle and create 2 circles. And now let's try to use the Contact Constraint command. For that, let's select the Contact Constraint command, select the edge of the rectangle and select the circle. So on selecting these 2 geometrical entities, we can see the circle has changed the position and now it is connected to the edge of the rectangle. In this case, the edge of the rectangle is forming tangent to the circle. So let's try this with the second circle too. So let's click on Contact Constraint command, select the edge of the rectangle, select the circle. So in this way, Contact Constraint can be used. Now let's try one more example. In this case, we will try to use this Contact Constraint for 2 circles. So let's select Contact Constraint, select the circle and select the second circle. In this case, the second circle has moved inside the first circle and the center point of both the circle has become common. Let's take one more example. Let's try to constrain a line. Let's create a line and let's try to constrain this line along with this edge of the rectangle. So let's click on the command, select the edge, select the line. This is the way the line is constrained. The line has taken a position which is in line with the edge of the rectangle. So this is all about the constraint in CATIA V5. Let's see the next features. Now let's learn about the next feature, Fix Together. Fix Together feature can be located on right vertical toolbar. Here you can see the tool fix together. It looks just like a paper pen. Now this is a feature which is used to fix a line, points, circle, arc or a geometry so that they do not change when other geometrical entities are modified. So let's try to understand in detail with an example. Let's create a geometry. If you remember manual editing, you can hold, grab and drag to modify the geometry. So let's try. Here when we are trying to modify any element, the adjacent element is also changing. Let's try this point. The same thing is happening. Let's try this entire edge and you can see the adjacent edges are also changing. If you want to prevent any relevant modification in the adjacent edges or a partial geometry, you can use this fix together feature and prevent the partial geometry from relevant modification. So let's fix these two edges. Let's select these two edges and click on fix together. So a pop-up window has opened. Here you can see some details are being mentioned. These details are of the geometry that we have selected. Click OK. Now these two edges or these two lines are fixed. Now if you want to change or modify any other edges, these two lines are not going to change. So let's try. So whatever you do, it's not going to change. So in this way, this feature is used to fix a part of geometry and prevent it from undergoing any relevant changes due to modification of the other part of geometry. Now let's try one more example. Create a geometry. Let's try to edit manually. You can see the relevant or the adjacent edges are undergoing changes. So let's try to fix part of a geometry. Select the geometry that you want to fix. Click on fix together command. Click OK. Now let's try to modify this geometry. Now you can see what was happening previously is not repeated now. This part of geometry is fixed and this geometry is not undergoing any changes due to modification of other part of the geometry. Let's try one more example. Let's try to fix the entire geometry. Select the entire geometry, click on fix together tool, click OK. Now the entire geometry is fixed. So this is the way the fix feature is used to fix a part of a geometry. Once you fix the part of a geometry, it will not undergo any relevant modification, neither you will be able to give any additional constraint to that particular geometry. This is applicable for a part of geometry as well as the entire geometry. Now this geometry we cannot modify manually. If we try to modify, the entire geometry is moving from its position, but it is not undergoing any change in its dimensions. Neither we can give any additional constraint to the geometry. If we are trying to give any additional constraint to the geometry, it is getting over constrained. So this is all about the fix together feature in CATIA V5. Welcome to this tutorial in Sketcher. In this tutorial we are going to see corner, chamfer and trim feature. With few examples we will try to understand how these features are used in Sketcher. Let us see how to create the corner feature in CATIA V5. To start off, open CATIA V5, enter into Part Design, click Sketcher, select the plane. Now you can locate the corner feature by clicking Insert, Operations. You can find the corner feature here. You can also locate it on the right hand vertical toolbar. So this is the corner feature. So let's try with an example. Corner feature is used to add fillet or corner to two sharp edges. So to start off, let's draw a rectangle and try to give the corner at each edges. Let's try to give corner to these two edges. Let's click on corner command, select the two lines and you can preview before you finalize the corner. Click it. You can change the dimension, double click on the corner. Here you can enter the radius. Let's enter 10. Click OK. So let's try to give the corner to all the edges of rectangle. Click on the command, select these two lines, double click, enter 10 mm, click OK. Select the corner command, select two lines, double click, enter the value, click OK. Select the command, select two lines, double click and enter 10 mm. So this is the way the corner command is used to create the corners or to give fillets at the intersecting edges. So this was very simple geometry where we have given corner or fillets. Each of the edges were at 90 degree. Let's try to take an example of a geometry having different angles other than 90 degree. Let's create a triangle. Let's give a measurement to this triangle. Now let's try to give corner to this intersecting edges. We can see the corners created at edges intersecting at higher angles need a higher radius to show the difference, whereas the corner created at edges intersecting at smaller angle shows noticeable change in profile with a smaller radius. This is all about corner feature within CATIA V5. So let's see the next feature, that is chamfer. It can be located by clicking Insert, Operations, and here you can find chamfer. It can also be located on right hand vertical toolbar. This is the chamfer tool. Let's see with an example how the chamfer works. Let's draw a rectangle and try to give chamfer at its corner. Click on the chamfer command, select the two edges and you can preview the chamfer. Click it. Now you can give the dimensions. You can change the length. Let us enter 20 mm. You can also give angle to the chamfer. So here we have originally minus 135 degrees. If you want to change it, you can change it. So this is the way the chamfer is created. Let's try one more time. Enter the value. Let's try one more time. So by default you can see it is taking 45 degrees. In the scale of 45 degrees. You can change this. Let us enter 30 degrees. And you can see the angle is changed. As this angle got changed, it has affected the previous chamfer also. So you need to take while creating the chamfer. So let's give chamfer to this corner. And give the dimensions 20 mm. Let's keep the angle as it is. So this is the way of creating a chamfer. Let's try one more example. Let's try to give chamfer to this corner. Let's try to give chamfer to this corner. Now you can give chamfer to chamfer also. Let's try to give chamfer to these two edges. So this is the way it works. That's all about chamfer in CATIA V5. So now let's talk about the trim feature. To locate the trim feature, click on Insert, Operations, Relimitations, and you can find a trim here. You can also find the trim at the right vertical toolbar. So this is the trim feature. You can use this trim feature to trim the geometry or to extend the geometry. Let's see with an example. Let's create few lines. And now let's see how the trim feature is used. So click on trim. Let's use this feature to extend the lines. Let's try to extend this line. So once you click on the line, you can see, drag it and you can extend manually. Also you can reduce it. Okay. Now if you want to extend this line and this line and want to make them intersecting, click on this line. So here what has happened, this line and this line both got extended and got intersected at a point. Let's try one more time. Click on trim, click on the line you want to extend. You can manually extend it. If you want both the lines to extend and intersect at a point, click on the next line. Let's try one more time. Let's try to complete this rectangle. This way the trim feature is used to extend the geometry. Now let's see how this feature is used to trim the geometry. Let's draw a line. Now if you want to trim this part of the line, let's see how we can do that. Click on the command, select this line. Now you can see once you play with the mouse, the line on which you are putting your cursor will remain as it is and the other part of the line is going to get trimmed. So in this case we have selected this line, and if you want to select this line, we will see the portion of the line got trimmed. Let's try one more time. Let's try to trim this part of the line. Select this line and select this line. So you can see the part of this lines got trimmed. Let's try to trim these two lines. Click on the command, select this line, select this line, and the exterior part got trimmed. Let's try one more time. Select this line, select this line. So this is the way the trim feature is used. Let's try one more example. Let's create a rectangle. Let's create a circle. So let's try to remove this part and create a single geometry. So let's click on the command, select the line, select the circle. Once again, let's click on the command, select this line, select this circle. So you can see the geometrical entity present here got deleted, and this has become a single entity. You can modify geometries by using the trim and extend operation. This is one of the important tools. It is very helpful to create sketches easily and speedily. This is all about trim and extend feature in CATIA V5. Welcome to this tutorial on Sketcher. In this tutorial, we are going to see break, quick trim, close arc, and offset features. So now let's see the break feature. This feature can be located by clicking Insert, Operations, Relimitations. Here you can find the break feature. You can also find it at the right corner here. So this is the break feature command. So let's see how it is used in CATIA V5. Let's take an example. Let's create a rectangle and try to break one edge of the rectangle. So click on the break command, select the edge or select the line you want to break, and click to create a breakpoint. So you can find this line is divided into two edges. Now you can drag this point up and down. You can also give dimensions to one of the edge and drag the point. So you can extend to 40 here, and you can see point that is breaking the edges has moved up. Let's try one more time. Click on the command, select the line and select the breakpoint, and you can see line is divided into two parts. You can drag this point. Also you can give the dimensions and fix this point. Let's try one more example. Let's create a rectangle. Let's create a line and try to break the edge of this rectangle by using the feature break. Click on the feature, select the line you want to break, and here you can click this line to break at the intersection. So click this line. So we can see this edge is broken into two parts by using break feature. Let's try one more time. Click on the command. Let's break this line into two parts. Select the line and we will break here by using this line. So you can see this line is broken into two parts. So this is a very simple feature and it's going to help you while making the sketches. So now let's see the next feature. There is a quick trim. You can locate this feature by clicking Insert, Operation, Relimitation, and you can find here quick trim. You can also find this command on right vertical toolbar. Here you can find quick trim. Let's see how it is used to carry out trim operation. Let's create a geometry. Let's create a rectangle, some intersecting lines, a circle. By using quick trim, we can trim these lines quickly. So let's click the command quick trim. Now if we click here, it is going to trim this line till the point of intersection. So let's click and see. Similarly, let's try one more time. If we are going to click on this line, this line will get trimmed till this point of intersection. Let's try to trim this portion of the circle. Click on the command, select the circle. You can see the circular part got completely trimmed. Now let's try to trim this part. Click on the command, select this line. One more time, click on the command, select this line. So this feature will help you to quickly trim the geometry. Let's see the next feature, that is close arc. This can be located by clicking Insert, Operations, Relimitations, and you can find here close arc. It can also be located on right side vertical toolbar. So this is the command for close arc. This feature can be used to convert arc into circle. So let's draw an arc. Let's draw a 3-point arc. Now by using close arc feature, you can convert this arc into circle. So let's click on the command, select the arc, and this is the way the arc is converted into circle. Let's try one more time. Let's create a 3-point circle. Click on the command, select the arc, and you will see the arc is converted to circle. This feature can also be used in case of spline. Let's see how it can be used. Let's draw a spline. Let's delete some portion of this spline. Let's break it. We have broken the spline into different parts and we will delete some of the parts. And now let's see how the close arc can be used to complete this spline. Click on the command, select the portion of spline, and you can see the entire spline is recreated. So this is all about the close arc. So now let's see offset feature in CATIA V5. To locate this, click on Insert, Operations, Transformation, and you can find here offset feature. You can also find this feature on right side vertical toolbar. You can find here the offset feature. If we have a complicated geometry, it will take a lot of time manually to reproduce it at a distance. Hence, offset feature will be useful. Offset can be done to part of geometry or entire geometry. Mostly circular parts are complicated and hence offset feature is very useful in recreating similar geometry at a particular distance. So let's take an example how an offset feature can be used. Let's create a geometry . So let's try to offset the portion of this geometry. So click this two entities, click on offset command, and you can see the offset part is created. Similarly, let's try to create the offset of this section. Create on the command, and you can see we are able to create the offset of the selected geometrical entities. Let's try one more example. Let's create a geometry. Now let's try to create the offset of these entities. So you can see the offset geometry is created. So this is the way the feature is used. This is one of the powerful tool in CATIA V5, and this is going to help you when you create a complicated geometries. So let's take one more example. Let's create a geometry. Now let's try to offset the selected part. Click on the command and you can see the offset part is created. You can see the geometrical shape also is changing, and we don't have to worry about that part. The CATIA V5 is going to take care of it. So this is the offset geometry, and this is how the offset feature is used. So let's see the next feature, that is complement. To locate the feature, click on insert, operation, relimitation and complement. You can also locate it on the right side vertical toolbar. So this is the complement tool. Now this feature is used to create the complementary part of the geometry. Let us try and understand with an example. Here we are going to take a arc. Now what is an arc? It is a part of circle, and using this complement you can create the missing part of the circle. So let's click on this command and click on this arc. So you will see that the missing part of the circle is created. Now let's try one more example. Let's take a rectangle, create a circle in it, just trim it. Let's trim the geometry, and now using this complement feature you can create the missing part of this circle here. So let's click on complement and click on the circular part. So this is the way the complement feature is used. Welcome to this tutorial on Sketcher. In this tutorial we are going to see mirror, symmetry, translate, rotate and scale feature. So let's begin with mirror feature. This feature is used to develop a mirror image of a geometry or a part of geometry. Most of the times the geometries are very complicated, and when there is a need to create the mirror image of it, it is very difficult to create manually. And this feature is going to help you to create the mirror image of any geometry or a part of geometry in a single click. So let's see how to create a mirror image of a geometry. So to start, let's enter into part design. Let's enter into Sketcher. Select any plane. Now you can locate the mirror command. Click insert, operations, transformation, and here you can find the mirror command. Similarly, you can find the mirror command on right hand side toolbar. This is the command for mirror. So let's see how to use this feature. So let's create a geometry. And now try to create the mirror image of this geometry. So in order to create the mirror image, let's draw an axis or a simple line. You can convert this line into a construction line in case if you want to use this geometry for creating a model. So this can be done by clicking on this point. So now it is a construction line. So to create the mirror image of the geometry, let's click on the command, select the geometry, select the line. Now you can see the mirror image is created. You can create in any direction. So let's try to draw one more line here. And let's make a mirror image of this geometry about this line. So click on the command, select the geometry, select the line. In this way you can create the mirror image of any part or any geometry. And it's not limited to the entire geometry, you can make a mirror image of its part. Let's try to make a mirror image of a specific part. Let's select the part of the geometry, click on mirror command, select the axis. So in this way the feature is used to create the mirror image. So let's see the next feature, symmetry. This feature is used to make a symmetrical geometry in CATIA V5. Now what is this application? Let us consider a situation where you are given a geometry which is being created by your colleague, which is a left hand part of a sketch, and it has some complicated geometries, and you are supposed to create symmetrical right hand part of the geometry. In that case, it is very difficult for anybody to use similar features has been used previously to create the left hand side part, and it is very time consuming. This is simplified in CATIA V5 by a feature called as symmetry. Using this symmetry, you can just flip it and you can create other side of the sketch. Let's try to understand with an example. Before that, we will see where you can find this command. You need to click on Insert, Operations, Transformation, and here you can find the command. You can find the same command on the right hand side vertical toolbar, that is here. Okay, so this is the command of symmetry. So let's try to understand in detail by taking an example of symmetry. Let's create a geometry by using a profile. Now let's try to make the symmetry of this profile. In order to make the symmetry, for that we need to draw a line, just what we have done in mirror. Select the geometry, click on symmetry and select the line. So you can see the geometry is flipped. Let's try one more time to flip it again to its original position. Select the geometry, click on the command, select the line. The symmetrical geometry is created. Let's take one more example. Let's try to make a symmetrical geometry of this profile. So let's draw an line, select the geometry, click on the command of symmetry, select the line. This is a way of creating a symmetrical geometry using the feature symmetry. That's all about this feature. So let's see the next feature, that is translate. This feature is used to translate the geometry from one position to another position. It can also be used to duplicate the geometry and translate the duplicate geometry from one position to another position. Now this feature is going to be a very useful feature when you are carrying out sketches of a large geometry. So let's see with an example how to use the translate feature. So you can locate the translate feature and insert, operations, transformation. Here you can see the translate. You can also locate it on the right vertical toolbar. So this is the command for translate feature. So let's see how to use it. Let's create a geometry. Let's create a circle and try to translate it using a translate feature. Select the geometry, click on the feature. Now here you can either create a duplicate of the geometry, of the selected geometry, or you can translate same geometry. Let's try to translate the same geometry. So click and then you can move. So wherever you want to place it, you can place it. So let's try to place here. So you can see the original geometry is translated. Now let's try to create a duplicate of this and translate it. So select the geometry, click on translate feature, click on duplicate. So one duplicate will be created. So let's click somewhere here and try to move. Okay. So in this way we are able to translate the copy of the selected geometry to a particular location. Let's try one more time. Let's select this geometry, click on translate. Let's try to make more number of copies. Let's try to make 5 number of copies. So click, and now you can see the 5 copies of the geometry you can translate. So this is the way the translate feature is used. This will be very helpful when you carry out the large geometries and you want to place a specific part of a geometry at other corner of the sketches. So this is all about translate feature. So now let's try to understand the rotate feature. To locate the rotate feature, click on insert, operations, transformation, and here you can see the rotate feature. You can also see it on right vertical toolbar. Here you can see the rotate feature. So let's see how to use it. Let's create a geometry. Let's create a circle and try to rotate this circle about a specific point of rotation. So let's select it, click on the command of rotate. Here you can see a pop-up window. You can create a duplicate geometry and rotate it, or uncheck it and rotate the original geometry. So let's try with the original geometry first. So first we need to define the point of rotation, and then you can click one more time and define the arm which will help you to rotate the geometry, and this is how the geometry is going to rotate. So let's try one more time. Select the geometry, click on the command. Let's keep it as it is. Select the point of rotation. Click one more time to define the arm which will help you to rotate the geometry. Now this is the way you can use this feature to rotate the geometry. Let's try to create the duplicate and try to rotate using this feature. So select the geometry, click on the command, click on duplicate. Let's create a one copy. Click for the point of rotation, click to create the arm. Now you can see you can rotate the geometry. Click. So one copy we have created and we have rotated. Let's take one more example of rotation. Let's create a geometry. Now let's try to rotate a single line of this geometry about this point. Select the line, click on the command. Now let's create a duplicate of it. Let's create one. Let's untick this. Click the point of origin, create an arm and rotate it manually and snap it. You can also define the angle between these two lines. Let's try one more time. Click the line, click on command, select the point of origin, create the arm, and now here you can define the degrees. Let's try 20 degrees. Click OK, and you will see that the line is rotated at 20 degrees. So let's try to rotate one more time with multiple copies. So let's say 5. Click for the point of origin, click the arm, and you can just drag it to rotate the lines. We can also enter the angles, let us say 5. Now here we need to click on this constraint conservation so that each line is rotated at 5 degrees from the previous line. Click OK. So you can see 5 more lines are created by using rotation feature, and all these lines are making 5 degrees with the previous line. So this is all about rotation feature. Let's see the next feature, that is the scale feature. You can locate the scale feature by clicking Insert, Operation, Transformation and Scale. The same feature you can also locate on the right vertical toolbar. Here you can find the scale feature. And the scale feature is going to be a very useful tool when you want to scale up certain drawings or certain sketches. Let us say if you have made a sketch with 1:1 scale, and if somebody is demanding for 1:3 or 1:2 for creating a prototype, in that case the scale feature is going to be very useful. So let's see how to use this scale feature. Let's create a geometry. Let's try to create the scale of this geometry. Select the geometry, click on the command. Here we have an option of creating a duplicate, or we can also scale the original. We will just keep the original and create a duplicate. So now we have to define the point which will be the starting point of the scale. And once we drag it, you can see the geometry is scaled. You can manually snap to the point, or you can enter the scale value. Let's say 0.5. Click on OK, and you will see a scale geometry is created with a scale of 0.5. Let's try to delete and try to see one more time. Let's try to create the scaled copy of a part of geometry. So let's select these 3 entities, select on scale command, select the point of scaling, and then you can drag it and see it is being scaled. You can enter the scale value here, let's say 5 times. So you can see this geometry is scaled up to 5 times. So this is the way the scale feature is used. It is really going to help you when somebody is demanding to scale up the geometry for creating a prototypes. Hi, welcome to this tutorial on Sketcher. In this tutorial, we are going to see sketch analysis and sketch diagnosis. Now let's see how you can analyze the sketch by using a sketch analysis tool. To start up, enter into part design, click on sketch, select the plane. You can locate the sketch analysis tool by clicking tools, and here you can find sketch analysis. Once you click on the sketch analysis, you will find a pop-up window, and this window will give you details of the geometry. It can be a single geometry, it can be a number of geometries in your sketch, and it will give you the detailed status of your geometry. Now what exactly it is going to tell you? It will tell you whether the geometry that you have created is a closed or open geometry. If some entities are missing or if some entities are overlapping, it is going to tell you. It will also tell you if there is a space between two entities. Knowing the status of the sketch is very important, as it will tell you if you can go ahead and use other features like extrude, or you have to go back and make some changes in your sketches. So this sketch analysis is going to help you for that. If the sketch is closed, it is perfect to use other features, or it can also be used in other workbenches. And if the status is open, you have to go back and make the changes. Let's start off. Let's try to make a geometry and try to understand sketch analysis in detail. So let's create a geometry. Now go to tools, select sketch analysis, and you can find a pop-up window. Here it is mentioned the geometry is implicit profile and the status is open. Open status means nothing wrong in it, but you cannot use the features like extrude. Now the open status is an indication that we have to go back and we have to work on our geometry to make it close. So let's try. Let's try to make it a closed geometry by connecting these 2 points. Now let's again go to sketch analysis, and now you can see the status is closed. Now this geometry is perfect to carry out the extrude operation, or this geometry can also be used in other workbenches. Let's delete. Now let's try to understand in more details by creating an additional point. So here you can see point by clicking command. Click on it and create a point. Now let's try to see what our tool says. Now it says your profile is open and you have an additional point, and that is an isolated point. So it is suggesting us that it is an unwanted point and it has to be removed. It can be removed by clicking, and you have a delete option here. So click on it and your point is removed. Now let's take one more example and try to understand. This time what we will do, we will try to create a very small gap between the 2 points. Let's zoom. Let's locate this point very close to the nearby point, and this gap is a very small gap. Now let's try to run the sketch analysis. It shows, the sketch analysis shows that the geometry is open and there is a very small gap, and it is highlighted by a blue color. So you can see the gap is highlighted by blue color, and it is suggesting us that you need to make a correction at this point. Now zoom and make the corrections, or you can also use a command that is trim feature and connect the points. Okay, so if you run sketch analysis now, you can see geometry is closed. Let's try one more example by creating two geometries. Let's create two circles and let's try to run sketch analysis. Now the analysis shows both the geometries are close. Similarly, it is going to show you all the geometries within the sketches and help you to check and recheck your sketches before using other features. That's all about sketch analysis in CATIA V5. So let's now talk about sketch diagnosis. It is also a part of a sketch analysis. Now let's see how we can use a quick geometry diagnosis. For that, let's create a rectangle, let's create a circle and quickly run sketch analysis. In sketch analysis, we can see an option diagnostic. Here the entire details about all the geometrical entities is shown. These are the geometrical entities and these are the status. The status can either be under constraint, over constraint or iso constraint. But it is expected that all the geometrical entities are iso constraint. So let's see how we can change the status. So let's click close and let's try to give dimensions to the sketch. Let's give dimension to the circle. And let's do sketch analysis again. Still you can find many of the geometrical entities are under constraint. So let's close it. Let's try to give the dimension to this edge. Let's try to give dimension to this edge. Let's make it 50. Let's make it 50. Let's run sketch analysis. Now you can see most of the geometrical entities are iso constrained. There are few which are under constraint, that is a circle, and this is the center point of the circle. Click the constraint, select the center point, select the edge of the rectangle. Let's make it 100. Let's fix the position of this circle by clicking on constraint and clicking the 0, 0 coordinate. So we have given the dimensions to the entire geometry, and let's try to run the sketch analysis. Go to diagnosis. Now you can see the entire geometry is iso constrained. Each and every part of the geometry is iso constrained. In this way, sketch diagnosis can be used to check the status of each entities of the geometry and make the necessary changes to make the geometry iso constrained. This is all about sketch diagnosis in CATIA V5.